Hello and good afternoon. Welcome to another Bedfordshire IMechE event. This one is entitled British Manufacturing Delivering a Soft Landing on Mars. So my name is Dr. Philip Bridgman and I'll be your host for today's event. And in the background we have Alex Harmond, who's doing the technical support. And it's my privilege we have a speaker today, who I will introduce shortly, Peter Hill from Heathcoat Fabrics Limited. And he's here to speak to us today. And if you're interested in getting involved in the IMechE, please don't hesitate to get in contact with us. So here's a short video introducing Heathcoat Fabrics Limited. So here's some information about Heathcoat Fabrics Limited. Heathcoat Fabrics Limited is the marketing leading manufacturer redefining technical textiles of knitted and woven fabrics based in Tiverton, England, UK. Their skills have been developed, honed and perfected over 200 years. They aim to solve complex challenges and convert opportunities into values for each customer. This approach has helped them forge a worldwide reputation for unmatched quality, new ideas and total customer focus. Their skills have enabled them to deliver a consistently high standard across multiple industries. They work with world-class suppliers to ensure their capabilities are always above and beyond their competitors, a no-compromise approach. However, their focus is not just parachute fabric, but also includes military-grade textiles, meeting the needs of the armed forces and law enforcement in equipment and clothing, and body armour, flame-retardant and heat-resistant fabrics for helicopter, tank and jet pilot suits, textiles for healthcare, belting fabrics for timing belts, fire PPE clothing and equipment, automotive hose textiles, to name but a few of the things they're involved in. Millions of us were glued to our television sets, well, I certainly was, on the 18th of February 2021, as the NASA rover Perseverance unmanned spacecraft entered the Mars atmosphere, and we held our breath to see if the parachute would open. Well, as we know now, the parachute did deploy, and the NASA rover Perseverance had a soft landing on the surface of Mars. What most of us didn't know at the time was the parachute fabric was actually made in the United Kingdom. And here is a short video of the deployment of the parachute fabric in the Mars atmosphere. So a little bit about our speaker for today. Peter Hill is a director at Heathcoat Fabrics Limited and has been with the company for over 30 years. Peter studied biological sciences at Birmingham University and leadership at Exeter University. At Heathcote, he has worked as an industrial engineer, a production manager, a general manager of a factory in the Midlands, and for over 10 years as a director responsible for developing, producing and selling a wide range of technical fabrics to the global market. So I think we're going to be in good hands today. So Peter, over to you.
Hi there. Thank you for having me today and allowing me to explain about the history of the company and the Mars 2020 project and what we're doing in the future. I need to go back to the foundation of the company to explain where our innovation comes from and where our global trade comes from. The company was founded by John Heathcote in 1808. He was the inventor of the first lace-making machine, mechanized machine, the bobbinet machine. In about 1816, he was having a lot of problems with people smashing up his equipment. He was based in the Midlands, in the Loughborough and Nottinghamshire area. Both his competitors and the Luddites didn't like the new mechanized machine. So he decided to move to Tiverton in Devon, 170 miles away, and set up in an old woolen mill factory, which is where I'm sat today in Tiverton in Devon. His workers actually walked all the way 170 miles to relocate down here. And the mill was used for woolen fabrics previously, mainly military fabrics for the Napoleonic Wars. And what happened at the end of the Napoleonic Wars is there was no demand for uniform fabrics. So there was an empty factory here and a willing workforce. John Heathcote went on to found the first factory school in the UK, as far as we know, the first factory school, and also global trade links. So he started a silk farm in Italy, for example, and that ties in with our history and parachutes in the future to come. So he set that up. He was self-taught in 5 languages. He was really a man ahead of his time. He invented the first steam tractor. We don't know about that anymore because it sank without trace. So, you know, he was the Elon Musk of his day. He was a real innovator, and that's the foundation of our company innovation. Going forward up to the First World War, and the Heathcote factory was used to start to make a lot of military products, not just uniforms, but also shells and munitions in general. And the Heathcote family was heavily involved in World War I. Unfortunately, Ludovic Heathcote, who would have been the heir to the factory, was killed during World War I in France. And unfortunately, the Heathcote family has done a lot of good service for the country, but has suffered very badly during its history, with one son of Ludwig's dying at El Alamein, and one in Normandy, and another in a plane crash. And the 4th son, Sir Derek Amery, was involved in Operation Market Garden, actually jumping one of our parachutes, and was badly injured and never had any children himself. So that's a bit of the history of the Heathcote family. In the 1920s, we started to weave fabrics, and we used the silk yarn that we were using for our knitted bobbinet product. So we were able to make very lightweight fabrics. In about 1919, the first parachutes were used and deployed from aircraft. So you can see we were available with silk fabrics right at the dawn of the parachute industry, and we were supplied some of those silk fabrics. And then in 1938, we had the opportunity to acquire a parachute company that had to relocate from the Czech Republic for obvious reasons, the Pack Parachute Company. And we actually made parachute fabrics and parachutes here in Devon during World War II. So Stafford Cripps, the Minister of Armaments, actually came here in 1945 to thank the people of Heathcote for all the work they did supplying parachute fabrics and parachutes, flare chutes, cargo chutes, the whole lot during World War II. So that's the history of how we became to be in the parachute business. Winding forward a few years to the 1960s, there was a decline in military spending in the UK, as we all know. We couldn't afford to carry on spending the money we had during World War II and afterwards. And also the Buy American Act came into play, which meant that we could no longer supply the US with parachutes and parachute fabric. So at that time, we ceased making parachutes, but we continued to make parachute fabric, particularly for ejector seats. So as you probably know, Martin Baker in the UK is a major manufacturer of ejector seats, and we supplied the parachute fabric for ejector seats. So this gave us an in into the high-tech side of the parachute industry, and really sort of leads itself into where we got into the space business, because Martin Baker then had an aerospace division and a space division within that, looking at making parachutes for European Space Agency missions. And so we supplied the parachute fabric. Our first space parachute fabric was for the Beagle 2 mission. As we all know now, the Beagle 2, the parachute deployed properly and it landed properly. It just didn't work when it got there. We also supplied the parachute fabric for the Huygens mission, which also successfully deployed. But these were relatively lightweight objects that were landed and were not extremely complex projects at all. And that's at that stage, we were only supplying parachute fabrics into Europe and only for the European Space Agency. In about 2005, we decided that we really wanted to go to the next level. We wanted to see what we could do. We could see that the space industry was increasing. We could see that demands were increasing for military parachute fabrics. People wanted to go with lighter weight fabrics that were high performance, high strength. Paratroopers are generally getting bigger. Everybody works out these days in the military, so they're heavier. They carry a lot more equipment, so the payload was a lot higher. So parachutes, if you couldn't improve the performance of the parachute canopy fabric, make it lighter and stronger, the parachutes themselves got bigger and bigger, which was a problem. So as I say, in 2005, we started our project, which is called our High Performance Parachute Canopy Fabric Project, which is a long title, but we started to work on that. We joined the Parachute Industry Association, which is the global body that specifies parachutes, how they're made, and the actual parachute fabrics for sports, but also for military. It's particularly strong in the US. And we started to attend all of the shows related to the parachute industry, which are mainly in the US. One was in Barcelona, but generally in the US. And we started to get our name known. We went to visit all of the people around the US that we could, that were involved in the space parachute business, the military parachute, and the sports chute business. So we put a lot of work into this. And one of the things we realized was that no one had really looked in detail as to how parachute fabrics perform and why and how to make them better. So we did quite a lot of research into this, and we found that the first stage is you have to start off with a yarn that's high performance. By high performance, we mean that it's got a high strength to weight ratio. It's got good heat resistance, because especially in, we were thinking mainly there about ejector seats. Ejector seat can, the canopy of a jet aircraft can get very hot, and that can damage the nylon and it can deteriorate over time when it's hot. And then also UV resistance. That's mainly for the sports parachutists who jump a lot of times, and they're generally jumping in high UV areas in California or Florida, etc. So we have to make sure that the canopy fabric doesn't deteriorate under UV stress. What we then found at this stage was that the yarns had been progressively made weaker and weaker, because the bulk of the business was for the military, normal troop carrying chutes, and people just wanted the cheapest possible fabric they could get due to competition. So they actually made the yarns just to meet specification in all of those three characteristics: strength, UV resistance, and heat resistance. They just passed spec. And that we felt wasn't good enough for the markets we were targeting, which were space and sports and high-tech military. So we developed our own yarn. We developed a product that was stronger in all those three characteristics. And we also, there was a demand for lighter weight, as we said, for strength. So we developed these products, and in 2015, we were ready to launch our new product range, our high performance range, which we did. We presented the product at the 2015 Parachute Industry Association Symposium and Exhibition, which was run alongside the Aerodynamic Decelerator Systems Conference in Daytona Beach that year, which is for all forms of aerodynamic decelerators for space and military, which was great for us. We could show this new fabric, and everyone was amazed at its strength and its resistance. And a lot of people came on and talked to us. It was very interesting. And I'll give you an example of why you should always speak to people at shows when they come on, because these three guys come on the stand, and we assume that they look like everyday guys that are normally, they could be parachutists, they could be PhD students, and but they ask more and more in-depth questions about the parachute fabric. So after about half an hour, I said, do you have a card? And these guys said, yeah, here's our card. And the three guys were all engineers working for NASA. So, that was great to spend the time talking to them. And these guys turn out to be really important in our story as we go along. So the show ends 2015. We go home. We don't know if we're going to get any business out of this. It's a new project. What will happen? We traveled around the States meeting all the key players. It was a good tour. And yeah, let's see what happens. 2016, we get a call from one of the guys, the NASA guys we met in 2015, and he says, we've been asking around. We need to upgrade our parachute fabric for this Mars 2020 mission. We're having some problems. Everyone we speak to, all roads lead to you guys. You make the ejector seat canopy fabric. You make the high performance stuff. We've seen your new products. We're really interested. Do you think you could help us out? So I say, well, obviously we say yes. We have a few conference calls. We talk about it, and we find out they've got a major problem. The major problem is they have to heat treat the fabric before it goes into space with a process called dry heat microbial reduction. They have to do this process because it's been found that when objects are sent into space, everyone had assumed that cosmic rays, etc., would kill all the microbes, and that turned out to be wrong. The Russians did some trials on the International Space Station where they put bacteria outside or exposed it to space conditions, and some of the bacteria and viruses survived, which they didn't expect. So they had to make it more rigorous, trying to kill all the microbes before anything went to space. So this has been done by heat treatment. So they start off with a US fabric, which they were planning to use, which they'd used before, but for other missions or based on the fabric they used before. But they were shocked that when they actually came to test it after the dry heat microbial reduction, they had lost 40% of its strength. And this was a big problem. And we knew exactly why that was. It was because the products had been cheapened just to pass the military specs and don't worry about anything else. So we had the answer off the shelf almost. Our fabric started off 25% stronger than the competition. And then after dry heat microbial reduction at high temperature for almost a week, our fabric actually gained 1% in strength, didn't lose anything. So our fabric, with the way we designed it, didn't lose any strength. Started off 25% stronger. The American fabric lost 40%. We ended up twice as strong. Basically, the American fabric wouldn't do the job. So they then asked us, or asked me, come out to the States next week. We've got to have a meeting. So I get on the plane and say, sure, I can come. Everything will be fine. Yeah, it'll be fine. Come over and see us. We need to see you next week. I get on the plane, fly over to the States, go to JPL, Jet Propulsion Lab, for the meeting. And I get there, this is in Pasadena, and they say, sorry, you can't come in because you're a foreign national and you have to fill in all this paperwork and get approval to come in because a government place. We can't come in. So we have to reconvene the meeting. So the only place we could have the meeting, this is with the NASA guys about this big problem, was at Starbucks. So Pasadena Starbucks was where I had my first meeting with NASA. official meeting, and we're in Starbucks doing the presentation about how, or they're doing the presentation to me, showing how the fabrics they intended to use didn't work. So that was interesting in itself that we ended up in Starbucks, and then they gave us a brief, and the brief was to make a fabric that was at least twice as strong as the fabric that they previously used. And this is on top of where they intended it to be. This is twice as strong before dry heat microbial reduction. But we couldn't increase the weight by double. It had to be a bit less than that because of the constraints on the weight, on the mass. So the good news is we went back, we redesigned a fabric, we produced it in record quick time, pulled out all the stops to do it, and we ended up producing a fabric that was 2.5 times the strength of the American fabric and only 1.7 times the mass. So it would fit into the already pre-designed unit for the parachute, and it would work. Then through 2016 and 2017, we made the fabric, delivered the fabric to NASA's manufacturer, which is Airborne Systems in California, and they made the parachute for the mission. And the tests to begin with. So there was an extensive number of tests carried out. The tests were carried out. The picture you can see is a test in the largest wind tunnel in the world, which is at the NASA Ames facility in near San Francisco. A huge. That's actually a proper picture of one of the trial parachutes being inflated, and that was one of the tests. They did deployments from the ground, firing mortars, because these have to be mortar deployed. They're not deployed like a parachute is with a skydiver. If you've ever done that, we throw a pilot chute and the pilot chute drags out the chute. It's mortar deployed. Did mortar deployments from Earth, and then they did 2 sounding rockets, or the Aspire rockets, which they fired up to I think 120,000 feet to replicate Mars' atmosphere. Deployed them at altitude to test that everything worked before going ahead with the mission. At this point, I've got to say as well, we met with, I don't know if you've seen any of the information about the system, how it's designed, and the sky crane, but it was done by a guy called Adam Steltzner. So Adam Steltzner is a really smart guy. We met with him, and after the first visit in Starbucks, we went back a few months later with a team of people, Eleanor Newsom, who designed the fabric itself, and one of our sales guys, and we met with the guys we'd met at the PIA show, and also Adam Steltzner, and their level of understanding so quickly about how parachute fabric works and how you could improve it was astounding, and certainly found out where all the smart people in America seem to be going, which is NASA, and they're really switched on. And he gave us a few ideas as well that we were able to incorporate into it. And during that time, after 2017, we were really waiting for the event to happen. From a Mars 2020 point of view, that was put in the background because that was a job done, and we were on to the next project. So to tell you some other things that we've been doing in the interim, the superlight fabrics, which were the base of this, the aim there was to achieve, in Americans use ounces, so we wanted to achieve the strength of a 0.9 ounce fabric with a 0.7 ounce fabric. That was achieved. That product has then gone into several applications, including commercial space applications, which I can't give you in any detail, but the fabric is used on a regular basis to take things up to space and back again. You can probably work out there's only a few people that are taking people and equipment to the space station and back again. And we solved a massive problem for these people because they needed to strengthen the lines of the parachute, the cords, but there was no more space to put any mass into the capsule. So the only way to do it was to lighten the weight of the fabric and lighten the thickness and the mass of the fabric to fit it in. And that's what we were able to achieve for them. Otherwise, they were at a real impasse. So that's been a big project we worked on since 2015 as well, following on from that show. And we're also working on the Exomars was going to be 2021, now 2023 project, the European Space Agency project to land a rover on Mars. And we're actually making that fabric at the moment for that project, which has had some problems. Unfortunately, it was delayed this year. They were doing some work and some trials scheduled in California early 2020, which had to be cancelled because of the COVID pandemic. So they couldn't launch last year. They missed their window of opportunity. So Exomars we're working on simultaneously while we're waiting for the landing. And then, of course, as you all know, we had the Mars 2020 landing earlier this year, which was really exciting. On the day that the Mars landing was going to happen, all of us were pretty relaxed about it because we knew all these trials had been done, everything had been done to plan. And actually, we were on the phone quite a lot over those few weeks with the US, with the parachute manufacturer, Airborne Systems, and with NASA, because we're actually all working on the next project for NASA, or the next two projects. So two projects we're working on for NASA at the moment are weaving optic fibers into parachute fabrics so that they can sense stress and strains in the parachute canopy, which is proven to be quite a challenge, but we're just dispatching some fabric this week, today. And then there'll be bigger trials to follow on, because no one really understands quite where the stress and strains are in a canopy fabric. And the belief is that that parachutes are over-engineered by a long way. And we need to try to minimize the weight if we're going to land bigger and bigger objects on Mars and other planets, for example, doing a human mission in the future. So that's one project we're working on. The other project we're working on is for the Mars sample return lander. So the idea is at the moment, the Perseverance is there collecting samples, but at some point we want to bring those samples back, and the Exomars will also be used to collect samples. But that means landing something quite large on Mars, a rocket, and bringing some samples back to Earth. So that will need the parachute canopy fabric to be even stronger and to be even higher performance. So that's what we're working on at the moment. So all this we were talking about on the day. And then, you know, I'm talking to these guys on the one end because they're not the same people that are working on the Mars 2020 project. So they're interested in their project going forward. And then my wife says to me, "There's only 10 minutes to go. You got to come down and watch the landing." So the landing was on the TV. I walked down to watch it. And at this point, I'm still pretty cool because everyone's been chilled out about it. It's we've done all the trials, but I've got to say that the last 7 minutes of terror, which was probably more terrifying for us than most people, because all of a sudden on the TV, the NASA people and other experts are saying, "Oh well, if things go wrong, at least we'll have learned a lot about it." And I'm thinking, well, we've never had a discussion that things could possibly go wrong. And they were saying, "Oh, and because we've got all cameras everywhere, we'll be able to see exactly what goes wrong." So now I'm thinking, this wasn't what I was expecting, to be having to actually imagine that it could go wrong. So that was a pretty terrifying process. But of course, it was a massive relief when it happened. And all of us were in communication with each other, everyone that was working on it at that point, to celebrate, because we couldn't be together because of COVID regulations. Obviously, we couldn't have a big group watch, which is what we would have liked to have done. Hopefully for Exomars in 2023, we'll be able to get together and all watch it and celebrate and have some champagne and have a great night. But wasn't to be this time. But a massive relief when it did land and everything was successful, everyone was happy. And then you've probably seen yourself straight away when it came out, the picture of it, I thought, what's that design? That design's a bit weird. You can see like the normal design is a balanced design with the orange, international orange and white parts. And if you see the photo that I think you can see on your screen, you'll see that there's that one section to the bottom is different from the others. That's so they can count around and work out which panel's gone wrong if anything goes wrong. So so they can always check back what's happening. But anyway, this parachute canopy for Mars 2020 was totally different. The design was the color design was really strange. So I rang my contact, and he said, "You'll have to work it out for yourself. There's a message in there, but you'll have to work it out," which I was not able to work it out. But it says "Dare Mighty Things." It spells out Dare Mighty Things. That's what's encoded in it. And Dare Mighty Things is the motto that Jet Propulsion Lab has on their walls everywhere, which is a good motto for space, because what you're saying is, space projects are difficult. They're really mighty things that we're daring. And I think gives them a little bit of a cop-out that, if it goes wrong, we dared it, but it didn't happen. But anyway, Dare Mighty Things. I think that was daring in itself, because normally the parachute canopy is balanced, and the air permeability might be slightly different on the orange portion from the white portion. They're different batches. There could be some difference in tension. So the feeling always is that have the balanced color distribution is the safest way to go. And actually, the guy that decided to put the pattern there is a guy called Ian Clark, who was one of the 3 guys we met originally in 2015 that came on the stand, and we thought maybe they were skydivers, and turned out to be NASA guys. So yeah, it was a pretty interesting thing to put on there. Made for a very good story, putting Dare Mighty Things on the parachute itself. I'd like to say, this isn't the only. It's not just parachute fabrics that we're working on for space. We also have a fabric that's within the life support system on the International Space Station. It's used in the system which creates hydrogen and oxygen from water for life support. And for all those people that say that the space is, what's the point in spending all this money? It does feed down into research for other things, because the development we did for the hydrogen creation fabric is now actually going commercial into green energy systems. So we're working with people that are making hydrogen production systems at the moment. The learning we got from the project for the International Space Station will be applied to the general market. So yeah, we've got an increasing amount of business in the space market, not just the parachute fabrics, but other products as well. And what we've learned on the parachute fabrics through this entire process is now informing our new developments for military parachutes and our new developments for sports parachutes as well. And then of course there's a new big market, could be new big market for parachutes for drones. Because if people are going to start using drones to deliver products around the world, there has to be some kind of safety system for those cargo drones not actually landing on people and hurting people or damaging property. So we're actually working with several companies on parachutes for drones. So going forward, we can see that lightweight system is exactly what they need, and the high strength. Of course, the question is, in a market like that, which is much more cost-driven, will our products work in that market? But at the moment, it's looking very, very, very optimistic. So that's an outline of what we've done so far in the space, how we got to be in the space market, and what we're planning to do in the future in that market. So thank you for listening. If you've got any questions, please let me know.
Wow, what a story. Thank you very much, Peter. I thoroughly enjoyed that. It's some history. That's some history from Market Garden, which is probably one of the biggest use of parachutes in our military history, I guess, all the way through to NASA and JPL. I'm very shocked that due to security reasons, you went somewhere very public, like Starbucks.
It's crazy.
The irony there is ridiculous. So I've had a lot of questions text to me. I think people chickened out of putting them onto the Q&A, but I've got quite a few questions in front of me. But we've got some questions through the system, so I'll quickly go through these. But thank you, that was a really interesting talk. So Mark Wilson has asked, do you have any contracts with drag racing companies to build parachutes for their cars? Yeah, we do. We supply, we supply to the US. Strad Safety, I don't think they'll mind me saying. Strad Safety is one of the biggest drag racing chute companies. Yeah, we supply them. And we actually supplied, because we have this problem, we're not allowed to supply the US military, but we have supplied a special Kevlar flame retardant
parachute fabric for the US military drag racing team. There's some good video of that. I'll just find it somewhere. And that's actually based on, we do the Kevlar brake chute, which won't burn, for the Eurofighter project. So we supply the chute fabric for the Eurofighter as well.
Wow. Okay. And that's for the UK military as well, the Eurofighter.
Yeah, all the militaries that have the Eurofighter, we supply the chute fabric for all of them.
Fantastic. Okay, so the next question is from Matthew Hamill. What sort of techniques are used to get a better strength to weight ratio, and what else sets you apart from the competitors? A particular weave pattern, for example, and if unique, how do you go about qualification for a parachute?
Right, that's a lot of questions.
It's disappeared from the screen, so I can't read it.
Let me go through some things. Okay, so some things I can say are, every process you put the yarn through damages it. You can start off with a really good yarn and you can still make a rubbish product and lose strength all the way through.
Okay.
So I'll give you an example of that. High tenacity nylon 6/6, which this is made from, with the heat and UV protection in it, which are additional chemicals, will cut through metal parts on machinery. So where the ripstop pattern, weave pattern is, over a period of time, it'll cut that pattern into the parts of the machine that it rubs over, and then those become burr points, which then will damage the yarns and cause the tensile strength to be reduced. So you have to make sure that the machines are highly maintained. You need to get a higher strength and more resistant metal parts to start with. Then you need to make sure that you're doing ultra maintenance on your parachute equipment, more than you do on any other equipment, anything else you're making. And that's every part of the process. So I said there about that's the weaving machine I'm talking about. That's the actual bed of the weaving machine. But the winders, it'll damage the winders which wind the yarn. It'll damage the mechanical bits of the machine. It will then, you get the same problem on the finishing processes. So everything has to be done to perfection to make sure that there's no damage caused throughout the entire process. Not the problem with that is, the reality of that is that your standard parachute fabrics that don't need it, they will still pass with it. People don't bother doing this process. But for the space stuff and the high-tech stuff, we have to do it more than anybody else. And I think I'm saying it here, and people will, our competitors will be able to see it if they choose to look upon it. But most people just aren't doing this process and don't know about it. When we first tackled it with the loom manufacturers, the machinery manufacturers, they wouldn't believe it until we showed them photographic evidence that it happens. So you can, that's one of the processes. You have to draw the polymer correctly. You have to choose the correct polymers. You have to buy all the top-notch stuff. You need to make it the yarn on the newest up-to-date equipment. A lot of the equipment out in the market is 50, 60 years old. What we're making on is equipment that's 5 or 6 years old. Wow. That's a whole process. Every step of it, you have to choose the right chemicals. Some chemicals will cause more damage than others. You're processing chemicals, you're processing pHs, the actual dyes you use. It's a huge topic. A lot of it's IP, of course. I can't go into everything, but it's it takes a lot to make it the right way. In terms of qualification, I know that well, I said the whole testing regime, massive testing regime to re-qualify parachute fabrics. Yes, it's very difficult, and the re-qualification is one of the reasons why the military and the sports chute market hasn't gone as far as it could do. So we're using old technology because re-qualification is too expensive. I guess that's a problem that you guys come across all the time, but we're always delayed by that. We could make better things. And I think that one of the good things about space is that, when you're in a war situation, look at all the progress that's made in World War II, because it had to be done. And really the benefit in saving lives was greater than the cost and the risk of lives. That's not normal. That's normally the situation. So in times of military conflict, a lot of stuff can be done. Sort of the space race is a substitute for that. It's not really, and there is a bit of a space race going on there with the Chinese, the Americans, and the Russians. And if we can do things in a peaceful way that move products along quicker, I think it's a good thing. I think that's why NASA is a big benefit, because really these projects with NASA have helped fund, and the European Space Agency, helped fund leaps forward in our technology, you know, which would only ever be done in wartime normally. So.
So another question here from Peter: are the yarns dyed in house?
The fabric is dyed in house. Yeah, we did the whole process in house. Yeah, and that's one of the problems the US has got, because in the US it's all done. The parachute market is run by converters, as they call them, that sit in an office in New York, and they get one weaver to do one bit of the process. Whoever's got it cheapest that week, you know, the cheapest yarn, the cheapest weaving capacity, the cheapest finisher, and then they put it all together, and they that's how they do it. And they're only interested in the mass market, which in the US is the US military being 50% of the global spend being the US, and the biggest parachute force around. You know, they can do that. So yeah, we do it all in house to control the quality.
That's really good. That's good to hear too. So a question here from Mark Wilson: are there any potential applications for your products for things like bulletproof vests, etc.?
We're making fabrics at the moment for bulletproof vests. We're working on that on several projects. Actually, the main thing we're working on is more the bulletproof vest market is a bit saturated. You know, there's a lot of people can do that. But what we're working on is, and we are doing some work on that, it's more the helmets, because helmets are heavy, as you know, and it's a real problem. So we're designing some fabrics that are much lighter in weight for the helmets, bulletproof helmets. That's the high tech part of it, maybe at the moment, that we're working on. Yeah.
Okay. There's a bit more information available on that on your website, I'm sure. So I think this is more of a statement rather than a question. This is from Dimitris. He says, fascinating presentation, and he's rather embarrassed to admit that in his 20 years of engineering, he's never come across in his mind that there was so much engineering in just fabric. So that's a nice comment there. Another question from Will Summers. Great talk. Many thanks for sharing. Do you see any application for carbon nanotubes or other novel materials in the future of fabrics you produce?
Yeah, we're looking at novel materials all the time, and carbon nanotubes have been talked about a lot, but yeah, we're looking at everything. I mean, at the moment, the big drive is to sustainable materials as well. So we've got a meeting on Tuesday regarding hemp fabrics for composites. We're already working on flax for composites. So yeah, we're looking at sort of both ends. It's more sustainable materials and really new high tech materials. That's the business we're in. We have actually thousands of products, and we're always innovating, and it's all niche market stuff. You know, that is exactly for us. Yeah, so we have an interest in that.
Okay. So another question here from Mark Wilson here. How about extreme levels of protection for AFVs? I'm not sure what that is, etc. Could fabrics be used as a protection against RPGs, for example? Would be a lot lighter than metal armor panels.
They are being used for RP, yeah, for protection, for yeah.
Okay, and he's very kindly. So
IUDs are the problem, aren't they? Improvised explosive devices. That's one of the problems. So yeah, the textiles are being used in the bottom of those vehicles as well as armor plating. Yeah.
Oh, brilliant! And so he just very kindly clarified there. So he meant by AFV, he meant armored fighting vehicles, which I think you just answered there. Yeah. Brilliant. So a few questions came through to me by WhatsApp and by text message. You mentioned your products are less used in the UK. What's the reason the UK is not adopting it? You're mostly overseas trade.
I think we're in niche markets that just aren't being done in the UK in large volumes, you know. So,
I understand.
You know, there aren't at the moment. There isn't anyone doing space parachutes in the UK. Martin Baker stopped doing it. There's a company called Vorticity that does a lot of development work, but they're not actually building the parachutes. So they do the development of the parachute systems, and then someone like the European Space Agency has them built by people based in Europe. Of course, you know, The difficulties of Brexit don't help us. I think those guys are thinking of relocating to Europe anyway. Yeah, we're in a fortunate position in that our products are so niche. To get the fabric into America, the Buy American Act really makes it difficult to sell to anyone that's government controlled, including NASA. The Berry Amendment to the Buy American Act makes it almost impossible to sell to the military. But we had to go through a lot of documentation to get our fabric into the States to replace the American fabric. And it was only really possible because the American fabric just wouldn't do the job. And with the support of NASA, we did that. And European Space Agency, we're going to have the same problem because previously, when we were part of the EU, we got in there under the rules they wanted to buy everything in Europe. Obviously, we're not in the EU, or in the EU. We're not in the EU now, but at the moment, our fabric is the only fabric that can do the job, so it's not on the agenda. But it doesn't make it easier. You know, we're up against those things, and I think you have to have something niche and special if you're going to supply to these. You know, if you're going to succeed in the UK, you've got something special, and it needs to be export, because there's a massive world market out there, isn't there? We've actually had meetings with the Indian Space Agency. They don't need our products yet, but we've presented all of this to them and they're interested. So we're in there for when they're ready, but they're not requiring it yet because they're not going that far. China and Russia, of course, have got their difficulties because our products could be seen as being dual purpose. They could be military, repurposed for military. So we really can't go there at the moment, unfortunately, with some of these products anyway.
So the same person you mentioned in the ISS, oxygen, hydrogen, fabric material being used. Is that not something we could use in the new nuclear submarine fleet that the UK is building? I presume I mean the astutes.
Yeah, I don't know. I mean, we'd have to, the end customer for that would be, I don't know if
MOD, I guess.
I don't know.
Okay. So you've been to space, you've been to the ISS, you've been to Mars. Is there did I read somewhere that you'd been to Titan? Is that?
Yeah, that's the Huygens mission landed on Titan. Yeah. So that was 2005. So that was another successful one.
Wow, amazing! Really, that's really exciting. Another question here, which is sort of says, I think you've answered that one already. And what is a good question? It seems a bit obvious. What is the fabric actually made from? What's the main material?
The parachute fabric for space, and the most parachute fabrics are made from high tenacity nylon 66. It makes its high tenacity with added UV and heat protection chemicals, let's say.
Okay, and then I think it's the same person. Oh no, someone else. What is the so during the testing, are the fabrics tested mechanically tested at cold temperatures? I presume to simulate Mars atmosphere, etc.
Not by us, but I believe that they are. I know that European Space Agency cycle test includes the hot process and the cold process as well, high temperature and low temperatures, and then testing whether the fabric still performs afterwards. But we do all the heat aging this. We do 1 week heat age it at high temperature and then check it all out. So we do all our own testing. We do accelerated UV testing here, and we do all the normal tests of air perm and tensile tears a lot.
So so the guys still listening, if you've got any more questions, please put them up now. We've just got I've got two more text questions to me. I think you may have answered this one. The British Space Agency has now been opened. Have you been approached by them for any future work or?
No, not yet.
Fingers crossed. Fingers crossed.
Yeah. I've tried to reach out to one of the people in the UK that's making or doing some work on parachutes, but I haven't been able to get hold of them or get them to contact back yet. I don't know what stage they are in their cycle of producing things, But the Americans are a long way ahead. They've been doing it for a very long time, But I was going to tell you one interesting thing about that. There's that the airborne systems in California, the two main technical guys are both Brits that run it. So there's two Brits running the show. On the technical side there, so that's quite a good connection, and also some of these people have got a huge amount of experience. one of the guys that's doing the development now still works. He must be 89 this year. He was 87 last time I met him, and he was still involved so he was involved on the Apollo missions. So that's what gave it away, that he must be getting on a bit. He's still doing it now. His son works for the company as well. He's just retired, his son. He's now working with his grandson.
That's fantastic.
He's got a great grandson just born. He must be about a year old now. So people like in the space industry, they love it. There's a lot of the guys that, you know, they just in it forever, you know.
Absolutely. Oh, I can imagine you just can't leave it alone. And one last question has come in here to me. This is a bit of a silly, well, I don't know. In the films, they talk about de-icing the parachutes before deployment. Is that real? Do they do that for yours? Presumably there must be some sort of trace heating, I think he's referring to sort of warm it up before deployment.
I think that's a good question, but there wouldn't be any ice, would there? Once it's travelled to Mars, there's not going to be any
moisture.
There's not going to be any moisture, you know. One of the things they worry about on the dyes and any chemicals added is that whether it will sublimate, you know, and then redeposit on cameras and other equipment. So I can't imagine there'd be any moisture. But I'll ask someone before the before actually another presentation.
Sure. So I think it's true. You think of all the movies, they do say that, you know, better heat up those parachutes before we deploy, you know, 2 blocks of ice kind of thing. I think it was Apollo 13 and others.
Yeah.
Interesting. And yours is heat treated, so it would be able to take the heat, I guess. Brilliant. Well, that brings the end of the questions. I have any questions, and no more has come up on the system. So thank you very much. I thoroughly enjoyed that. I think it came across that way. Thoroughly enjoyed that, Peter. And I can't believe the history of the company goes back 200 years, all the way back to back in the proper mill.
Yeah, that's right. Yes.
Fantastic. I hope all the best for the company in the future. It's fantastic. So this, ladies and gentlemen, this recording will be posted into the IMechE YouTube channel. Feel free to rewatch it, and also please pass on the links on to colleagues who may have missed this presentation. So we have actually got, so thank you very much, Peter. I really did enjoy it. We've got some other future events coming up, which I should quickly mention. We've got an event on the 12th of July coming up, which is Making Beyond Possible, an introduction to reaction engines in Sabre. And I can tell you now that the tickets are selling very quickly for this one. So if you do want a ticket, please book this afternoon or this weekend. But that's another great IMechE talk brought to you by the Bedfordshire team. And on the 7th of July, we're organising presently the Superpowers of Neurodiversity. And we've got input from the British Dyslexic Association and the National Autism Society, talking about autism and dyslexia and neurodiversity in general, and the benefits, the superpowers, as it were, to the individuals concerned and the employer. So that should be really interesting, and we hope to see you at either of those events. So, ladies and gentlemen, thank you very much for attending, and thank you again, Peter, for a fantastically interesting talk. I'll bring this to a close. Thank you very much.
Thank you.